A construction manager is hired to build a bridge to connect two floors of a pair of skyscrapers. So I'm going to draw our buildings on this whiteboard so you guys get a feel of what I'm talking about. So we have two buildings right here, and the person who is hiring us would like us to build a bridge connecting the top two floors as a walkway. So in order to be able to do this build, the first information we're going to need is the distance in between these two buildings. So in order to do that, I'm going to create a triangle using these 3 points in order to use the law of sines to determine our distance. So I'm going to draw this triangle out on the board and make it bigger so that way we can complete our problem. So we have our triangle here, and we do have some information we can go ahead and plug into our triangle that was given to us. So the footage of one floor of this building is 25 feet. So that would mean that side B is 25 feet. And we also used a rangefinder standing on the floor of our building, measuring across to the roof of the building across to give our hypotenuse 100 feet. So we have our hypotenuse and we have the length of side B, and we can also see that this is a right triangle, meaning that the angle C is 90 degrees. So this is all of our given information, and we're going to use this information to go ahead and find angle B, angle A, and side A, which is the distance in between these two buildings. So to find angle B, we're going to use the law of sines. The law of sines states that side A over sine of angle A is equal to side B over sine of angle B which equals side C over sine of angle C. So in order to find angle B, we know that sine of angle B must equal side B sine of angle C over side C. So we're going to plug in our given information into this equation, and we're going to use the inverse of sine button on our calculator to get our answer. So we have 25 feet for side B, sine 90 degrees over 100 feet. And that gives us 14.5. So we know that we have an angle of 14.5 degrees for angle B. And now that we have angle B and angle C, we can simply subtract that from 180 in order to give us angle A. So we would have 180 minus 90 minus 14.5, which gives us 75.5 degrees. So angle A is 75.5 degrees. So now we have our triangle filled out. We have all the information necessary in order to find the distance in between these two buildings, or side A. So to find side A, we just simply use our law of sine again, which states that sine of side A equals side C sine of angle A over sine of angle B. So we're going to plug in our information and then plug in this equation into our calculator to get our distance. So that would be 100 sine of 75.5 degrees over sine of 90 degrees. And this equation plugged into our calculator gives us 96.8 feet. So the distance in between these buildings is 96.8 feet. And now that we have the distance in between the buildings, we can go ahead and start the construction, start the project. And this is how you use trigonometry in construction management.